Hi everyone, let's solve this math problem together. We know that the area of this region plus the area of this region divided by the area of this region is equal to 2 pi minus 1. So our goal is to find the value of alpha. So let's first express these three areas as a function of alpha. I think the second region is the easiest. Also note that without loss of generality, we can assume that the radius is equal to 1, since this will be the easiest value to work with. So now let's use this formula, which gives the area of a triangle. And by the way, I'm working in radians all the time, so pi is equal to 180 degrees. So the area of this region, region 2, becomes r times r, which is 1 times 1, divided by 2 times the sine of this angle. This angle, since this is an equilateral triangle, this is also alpha, and this will be pi minus 2 alpha. So we get that the area is 1 over 2 times the sine of pi minus 2 alpha. Now let's calculate region 1. To calculate region 1, I will write the region as 1 plus 2 minus 2, since we already have calculated 2. So for the area of 1 plus 2, we can use this formula. So let's do that. The area becomes this angle in radians, which is pi minus 2 alpha, divided by 2 times r squared, which is just 1. And then we have to subtract the area of 2, which is the value we already knew, which is 1 over 2 times the sine of pi minus 2 alpha. But now, since this angle is pi minus 2 alpha, that means that this angle is exactly 2 alpha, and the region 3 is also easy to calculate. So region 3 is this angle, 2 alpha, divided by 2, is what the formula says, and then times r squared, which is 1. So this is just alpha. So now let's use what we know. We know that 1 plus 3 over 2 is equal to 2 pi minus 1. So this gives us that 2 pi minus 1 times 2, which is 1/2 times the sine of pi minus 2 alpha. This is equal to 1 plus 3. So that is pi minus 2 alpha over 2 minus 1/2 sine of pi minus 2 alpha, and then plus alpha, which is equal to the area of 3. So let's now clear the board and solve this equation in alpha. So what is left to solve is this equation. Now notice that if we distribute this minus 1, that this will cancel out with this term, minus 1/2 times the sine of pi minus 2 alpha. And also notice that the minus 2 alpha over 2 will cancel with the plus alpha. So what is left is 2 pi times this, which is pi times sine of pi minus 2 alpha. And what is left on that side is exactly pi over 2. So this gives us that we need to solve for sine of pi minus 2 alpha is equal to 1 over 2. And what I would recommend to do now is draw a geometric circle where this is 0 and this is 1. And we know that the sine, which is a projection on the y-axis, which is also between minus 1 and 1. So the value of sine has to be 1/2, which is here. So that corresponds to this angle. Let's call that alpha 1, but also to this angle. And let's call that alpha 2. So these both have the sine equal to 1 over 2. Now either you memorize these angles or you know this triangle, which is a 30, 60, 90 triangle, and the values 1, square root of 3, and 2. And then we see that the sine of 30 degrees is exactly 1 over 2. So we know that alpha 1 is 30 degrees or pi over 6. And alpha 2 is equal to 180 degrees minus 30 degrees, which is 150 degrees, which is 5 pi over 6. So now we can solve our equation. We know that pi minus 2 alpha is either pi over 6 plus 2k pi, or pi minus 2 alpha is equal to 5 pi over 6 plus 2k pi for some k in z. But notice that alpha should be between 0 radians and pi over 2 radians in our problem. So let's solve for alpha. That means that 2 alpha is equal to pi minus pi over 6, which is 5 pi over 6. And then minus 2k pi, or 2 alpha is equal to pi minus 5 pi over 6, which is pi over 6, minus 2k pi. But now notice that since we search the solution in this interval, we can just remove these two terms since they are irrelevant. And then we find that alpha is equal to 5 pi over 12, or alpha is equal to pi over 12. And if we now compute this into degrees, then this becomes that alpha is equal to 75 degrees, or alpha is equal to 15 degrees. And that are our two solutions to the problem And if you made it this far in the video, don't forget to like and subscribe.